Hello all. Today we are on lab 9. So let's go back to our lab manual. So lab 9 is on absolute extrema. So there are few basic things that we must know, and then let's get on to our actual stuff. So I've created a Matlab code on this, which has all the necessary details that you're supposed to follow while during your assignment as well. So try to follow the same and you would be good. Okay, so what is an absolute extremum? So absolute extremum of a function in a given interval is the point at which a maximum or minimum value of a function is obtained. So say you are given a function, and if you are asked to find absolute extremum, you are supposed to find two things. One is your maximum value and a minimum value of a function on a given interval. Okay, as I said, we have to know a few basic things, and I have divided that into four categories. One is to check the truth of a statement. Okay, let's say if I have 1 plus 2 is greater than 4, which is false because 3 is not greater than 4. So Matlab is going to give you 0 as on the output screen, saying that the statement is false. Say if the statement is true, say 1 plus 2 plus 3 is greater than 4, which is true, Matlab is going to show you 1 as on the output screen, representing that the statement is true. Okay, second part is we will have to solve many equations for its roots. We have done this before in our previous classes, so we are going to look at it again. Okay, so you can do that using mysolver.m file. So go back to your lab manual. You will find Matlab script file, function f file. Copy that and paste it in your script file and not on the lab script. So copy the function on your script file just the way I did it right here. Save it just like the way I did it. Save it in the name of the function itself. Then define the variable x, then the function. So the function is x squared minus 2, like that. Then if you solve the values for x, you will find square root of 2 and negative square of 2 as the answer. So these two solutions is going to give you the two solutions that you got. Say a is equal to all solutions at 1, so negative square of root of 2, which is actually comes before positive square root of 2 on the real line, isn't it? And then we have all solutions 2, that's positive square root of 2. Now there is another one that is using VPS solver. So if you use that, we have seen this again. On the negative side, you have negative 1.4142, which is actually the decimal of negative square root of 2. On the positive side, it is 1.414, which is actually the decimal of square root of 2. Then the last thing that you must know is to know how to create a random number. So let's say if you want a number closer to 2 in the difference of 0.05, this is what you do. Let's say close is equal to 0.05. Number close to 2 is equal to 2 plus RAND parenthesis minus RAND times close is going to give you an interval of that kind. And if say, for example, if you want a number closer to 1 plus or minus 0.5, you just have to change this number to 1 and that one to 0.5. So in that case you will have a number within the interval 1 plus or minus 0.5. So from this I have 1.984142. So this changes all the time because you're creating a random integer whenever you run a code. Next step is graphing a function and its derivatives. So you need to know this. This is also one of the basic. Okay, so graphing a function derivatives, you have done this before. Let's say you have a function x squared minus times secant x. X squared times secant is your function. First step first, you define a variable, then the function. Now you are asked to plot two functions. One is your main function itself, and the other one is your derivative. So you can plot f of x using easy plot command. Hold on, plot the derivative of the function f of x again. So that we have seen this earlier, so we are going to follow the same thing. Next step is to find c value. I'll let you know what a c value is. So c value is a critical point. Now we have to find that. VPS solve df of x at x in the interval -4 to -2. So I'm again creating a random number, say close is equal to 0.1, just to check the statement after all. Alright, now how do you find absolute maximum and absolute minimums? This is what you do. Take a derivative of the function and equate that to 0. First step is take a derivative of a function and equate that to 0. That is what I did there. Then after you equate that to 0, solve for x. Solve for x, and there you will find c value, which is called critical point. So critical point is nothing but the x value that you got after you take a derivative of the function and equated that to 0. So that is what we are going to do here. Okay, this is the actual question that we are going to do today, that is finding absolute maximums and absolute minimums. And before that, I'm asking you to read two theorems about extremum values of a function. So kindly read that from your lab manual and you would be good. Okay, let's get started with this. Let's say you have an equation f of x as sin x plus x times cosine of x squared, and the interval is 0 and pi. So this is what you do for all the questions that is given on the assignment. This is what again you do. Define the variable, then the function, then the two intervals that is asked to find. So I have a is equal to 0 and b is equal to pi. So look at that, 0 to pi is 3.1415. So that is what you have. Then plot the two functions. Plot f of x in the given interval, plot derivative of f of x on the given interval. Before that, you must not forget to take the derivative of f of x. So hold it off. You hold on there, you hold it off there. You may not do this, but take it as optional. Switch on the grid for easy access. Now, first step is to find critical point. Now, how do you find critical point? You take a derivative of the function given and equate that to 0 and solve for x for the derivative function. Now look at the graph. You have two different curves. One is the blue line and the other one is red line. So red line is your derivative curve and the blue line is your main function. Now to find critical points, you always follow the derivative line. So look at the derivative line and see where it is intercepting with 0. That means you have f prime of x equal to 0. So if you find an x value to f prime of x, and if you plug that x value to your derivative function, you have to see a 0 on the output screen. So basically you're finding the roots for the derivative function. So next step, I'm trying to find c values, that is the critical points. So follow the red line, use this code, c1 is equal to VPS solve df of x at x at this interval. Now let's look at the curve. You have 1, 2, 3 and 4. So you have 4 critical points because there are 4 points at which the curve of the derivative function is meeting 0. So the first intercept right there is between the interval 0.5 and 1. That is what I have right there. And the second intercept is between 1.5 and 2. 1.5 and 2 I have right there. And the third meeting point at 0 is somewhere between 2.3 and 2.8 approximately. And C4 is this point. So it's between 3 to some 3.3 or 3.4. So I've taken 3.3, that is fine. Okay, so those are my critical points. So my critical points are x values, and if I plug in to my f prime of x, I should see a 0. Okay, now after I find all the critical points, I plug back to the function, to the main function, like that, in the form of columns, along with a and b, because a and b are my intervals, isn't it? So f of a and f of b, I used VPA to convert. I mean, I saw this answer as in fractions, so I just wanted to convert that to decimal, so I used VPA. So f of a, c1, c2, c3, c4, along with f of b, you will see a column with all these solutions. Now look at the column and then decide which one among those is maximum and which one among those is minimum. So out of these, I found to be the maximum value is found to be 3.100, and the minimum value is found to be negative 3.0155. All right, this is what you do. All right, then as far as assignment is concerned, you just have to change the equation and its interval a and b on the code, then look at the graph and locate the intercept and its interval to find c values. Finally plug them in the column format and then find the maximum and minimum value out of it. So follow the red line because that is the derivative line, and you have to find the x value. See that the x value that is making your derivative function 0. So to find that, you have to locate the interval where the graph of the derivative function is meeting at 0. So I've located all those and I plugged it back to my function, and I found the answer looking at this column. Say if you have just 3 intercepts, you will have 3 critical points, that is c1, c2, c3. You can get rid of c4 and plug it here, leaving behind, I mean, you can take out f of c4 and you will have 1, 2, 3, 4, 5 solutions. Look at the column and then decide which is maximum and which is minimum. So that's it for today, and I hope this is going to be easy after this.